In this video, we're going to look at the Corbett's Conundrum from the 3rd of January. And that conundrum says, prove the sum of 3 consecutive integers is divisible by 3, and that the sum of 5 consecutive integers is divisible by 5, but that the sum of 4 consecutive integers is not divisible by 4. If you haven't tried that conundrum yet, press pause, and whenever you're ready, press play, and you'll see the solution. Okay, so let's go through this conundrum. So what I'm going to do is I'm going to start off by writing actually 5 consecutive integers down algebraically. So let's let the first integer be n. The second integer, well, that's going to be the next one, so that'll be n plus 1, because remember they're consecutive. The next one will be n plus 2. The next one, n plus 3. That's the 4 so far. And the fifth one, n plus 4. So that's 5 consecutive integers. And now what we're going to do is we're going to look at each one of these separately. So first of all, let's look at the sum of the first 3 and prove that that's divisible by 3. So the first 3 integers, well, if I add those together, that's n plus 1 plus n plus 2. Now when you add those together, you get 3n plus 3. Now if we factorize that, taking the 3 out, we're going to get 3 bracket n plus 1. Now that's 3 times, remember n's an integer, so that's an integer plus 1, was just another integer, times by 3. Well, that's going to have to be a multiple of 3. So therefore, it's going to be divisible by 3, divisible by 3. So that has proven that the sum of any 3 consecutive integers is going to be divisible by 3. Now we're going to look at 5 consecutive integers, so if we just rub that out. And let's look at the next bit. So the next one says, prove the sum of the first 5 consecutive integers, prove the sum of 5 consecutive integers is divisible by 5. So if we add it together, 5 consecutive integers, any consecutive integers, let's see what that gives us. So n plus 1 plus n plus 2 plus n plus 3 plus n plus 4. Now adding together the n's, that's going to be n, 2n, 3n, 4n, 5n. And adding together the numbers on the end, so 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So that's going to be 5n plus 10. Now again, we want to prove this is divisible by 5. So let's factorize it by taking 5 out. So that gives us 5 bracket n plus 2. So again, that's 5 times, and remember n's an integer, so that's just a whole number, and a whole number plus 2, another, that would just be a whole number, an integer. And when you times that by 5, that's going to be a multiple of 5. So this shows that this is always a multiple of 5. So therefore, we know that it's going to be divisible by 5. Divisible by 5. Okay, so that's the first 2, and now the last bit is to show that whenever you add together any 4 consecutive integers, that any 4 consecutive integers will not be divisible by 4. And what I'm going to do is I'm actually just going to keep what I've got there. So here we've got any integer, the next one, the next one, and the next one. So it's 4 consecutive integers, and let's add them together and see what we get. So that's going to be n plus n plus n plus n, that's 4n. And then 1 plus 2 plus 3 is going to be plus 6. Now if we look at this, we can't actually factorize this by taking out 4. We could take out 2, but we can't take out 4. And let's actually look at it a bit more. Well, 4n, well, that's going to be a multiple of 4, because 4 times a number, but we're adding 6. Now if you've got a multiple of 4 and you add 6, it will be an even number, but it won't be a multiple of 4. It'll be, it's going to be 6 more than a multiple of 4. So because we can't factorize it by taking out 4, therefore it won't be divisible by 4. So that's sort of showing it that we can't be, we can take out 2. We can prove it's even by taking out 2. We can't take out or factorize by taking out the 4. Because we can't take out the 4, then it's not divisible by 4. And again, just breaking it down, 4 times n, remember n's just any integer, so that's going to be a multiple of 4. But if we add 6, that definitely won't be a multiple of 4, because a multiple of 4 plus 6 is, so I suppose it's going to be even, but it's not going to be in the 4 times tables. And that's it. So so therefore not divisible by 4. And that's it.